Hello friends. This morning the video is about solving a 3-equation system with 3 variables. So if I gave you the first 2 equations without the third, this would be unsolvable. This would intersect an infinite amount of time, so you couldn't find an exact intersection. There'd be many different combinations of x, y, z that could satisfy both of these equations. But when you look at all 3 of them, you notice we have 3 equations in how many variables? 3 variables. So actually that is enough to solve and find an exact solution of which XYZ combo fits in all 3. So you can imagine if we had 4 equations and 4 variables, that would work too. 5 equations, 5 variables, that would work too. The great news about this is the same 2 methods you've been using, elimination and substitution, are still going to work for this. The only advice I have for you, and the reason I'm making a video, is because it's easy to get overwhelmed. So here's what I'd encourage you to do. I would encourage you to very carefully keep track of what you're handling. So I'm going to call these equations 1, 2, and 3 on my paper. By the way, this is just a made-up problem. It's not from your textbook, but it should help you with 8-2 part 2. So I'm going to call them 1, 2, and 3. Can anyone, I'm talking as if you're right there in front of me. It's fine. I'm not crazy. Can anybody figure out where elimination would work really well already? I see a couple options for where it would work really well already, but I'll just take it this way. I'm going to pick 2. This is a method that I call the you pick 2 method. That might sound like a familiar phrase, and that's because it's copyrighted by Panera. They have the You Pick 2 meal that you can go get curbside or in the drive-thru these days. But anyways, this is my You Pick 2 method. Some of my students in past years have named it the Mick Pick 2 method, whatever you want, but we're going to pick 2 equations of the 3. Okay, so the 2 that I'm choosing to pick right now are 1 and 2. Because it looks like if I do elimination on them right now as they are, what variable will cancel out? Z will. Okay, so we're going to do this. We're going to do x plus x, y plus 2, negative 2y, okay, and negative z and z, good, equals 5. Great. That's the beginning of the you pick 2 method. That's your first time picking 2. We are going to name this equation that came out equation number, well, 1, 2, and 3 are already taken, so equation number 4. This is not the answer. It's just going to be helpful. So anyone want to guess what we do next in the you pick 2 method? You pick 2 more. You pick a different combo of 2. So I can either pick 1 and 3 or 2 and 3. I already picked 1 and 2. So now I have to pick 1 and 3 or 2 and 3. Now what you want to do is you want to pick ones that are going to cancel the same number as last time. I should add that. Pick a different combo of 2 that eliminates the same variable as last time you did you pick 2. So what variable was eliminated back there? Z was. So I think a good choice for which combo could eliminate z pretty easily is going to be 1 and 3. It's not going to be as easy as last time, but it'll be pretty easy. Okay, so I'm going to do 1 and 3. Actually, let me just move over here. 1 and 3. So 1 is x plus y plus z. 2x minus y minus 2z. Okay, so why is this not as easy? Because if I try to add right now, the z won't eliminate. What do I have to do? Well, in elimination, when you're not getting what you want, you can just know that equation rules allow you to apply either equation by anything, as long as you apply it all the way through, and you can change it. So if I want to eliminate the z's, what do I want to multiply the top equation by? Positive 2, because I want positive 2 and negative 2z to cancel out. So everything is being multiplied by 2 on both sides of this equation. So this is going to become 2x plus 2y plus 2z equals 8. That's my new equation number 1. And my equation number 3 remains as it was, 2x minus y minus 2z. Okay, now it's time to eliminate. Great. What do you think I'm going to name that new equation that I just got? I'm going to say number 5, because number 1, 2, 3, and 4 are already taken. And here's what's great. When you get to this point, the you pick do method did you good. Because if you take equation 4 and equation 5, that's 2 equations. And how many variables, how many distinct variables do 4 and 5 have? Only 2 variables. They both only have x and y. Get it? So if you eliminate z twice, then you only have 2 with x and y. Now you don't have to eliminate z. You could have eliminated x and had 2 equations with y and z, but whatever. So we'll finish this off. This was 2x minus y equals 5. This was 4x plus y equals 7. Do they eliminate right now, or do I have to manipulate one of them? Looks like the y eliminates right now. Okay, so that's 6x equals 12. That means x equals 2. And that's huge news. We need to find the other 2 variables still, but at least we have this good news. Okay, where do we want to plug this back in? We don't want to plug x equals 2 into 1, 2, or 3. You know why? That's still too many variables left. There's still y and z left. And there's ways you could get this done by plugging them into 1, 2, or 3, but I think there are some easier ones. What number equations did I not mention? 4 and 5, right? So choose to plug it into either 4 or 5, whichever one looks easier to you. I think 5 looks easier, but that's just my opinion. Okay, so number 5 is 4x plus y equals 7. So I'm going to say it's 4 times 2 plus y equals 7. 8 plus y equals 7. And bada bing, bada boom, I found y. Now, if I want z, because I have x and y, and all I need is z, I'm not going to pick equation 4. I'm not going to pick equation 5, because those don't have z's in them. I have to go back to the beginning. I have to pick either 1, 2, or 3. It's your choice. Whichever one looks easier to you, any 3 of them will work. All right, so let's go back. So we got 1. X plus y, and I should keep better track of what I'm doing. X plus y plus z equals 4. If you don't label these 1, 2, 3, 4, 5, you are just really not going to be able to check your work if you have a mistake. So I really do think you need to be careful as you label in your notebooks. Okay, that's enough preaching. So x plus y plus z, it's substituting for me, that's fine. It's 2 plus -1 plus z. So that's 1 plus z equals 4, that's z equals 3. All right, so we've got all 3 of our solutions. I mean, all 3 parts of our one solution. There's one solution to this system of 3 equations and 3 variables. You can write it like this, but there's an even nicer way to write it. You wanna know what that is? It says an ordered triple. So I'll write that down. Ordered triple, which is the same as an ordered pair, which you may remember is what a point looks like, x comma y. But an ordered triple, you guessed it, will have 3 components, not 2. So we're going to write them in alphabetical order, 2, -1, 3. That is how I want to see your answers. All right, that's the end of the question, but what did this all mean? I have this great resource for you that I put on Classroom that is a 3D graphing calculator. I guess I should have asked you. If x plus y equals something, makes a line, like y equals mx plus b makes a line. What do you think happens when you add a z into it? What shape do you think it makes when you add a 3rd variable? So it's no longer going to be in the 2-dimensional plane. It's going to be in the 3-dimensional plane. This is a 3D graph that you just solved the answer to. It turns out that there's 3 things that intersect in the point 2, -1, 3, which is like 2 over -1 this way and 3 up. So it's something in the 3D plane that hovers around here. I don't know if you can picture what I'm doing. It's hard to do on a 2D screen. But what shape are those? Is it going to be 3 lines in the 3D plane? It's actually going to be 1 step up. It's going to be 3 planes. So I've got this cool calculator, and I'll just show the things one at a time. So here's my first equation, graphed in blue. This is a plane. I can kind of move this around and start to understand that this is a flat, like piece of paper-like thing, and it goes on forever. That's the gist of a plane, okay? It goes on forever in those 2 dimensions of the 3 dimensions, but it's infinitely flat. So it's like a piece of paper that goes on forever. All right, ready? Equation 2. So that's the green one. How many times do plane 1 and plane 2 intersect? How many times do the green and the blue plane intersect? Can you tell? That's actually an infinite amount of time. That's why you can't find the answer by just using equations 1 and 2. You have to involve equation 3 at some point. Ready to involve equation 3? Here we go. We got the pink one. If you look at just the pink and the blue, they intersect an infinite amount of times. If you look at just the green and the pink, they intersect an infinite amount of times. But if you look at all three together, and we swirl this around a little bit, can you see the intersection point where they all three come together? I see it. It's right there. Okay, so I'm going to try, oh, I don't know what I just did. Cancel. Okay, I'm going to try to put our potential answer in and see if that little point is truly at what we said it was. So we're thinking the point is 2, -1, 3. Let me graph that. 2, -1, 3. Graph. Where is it? Do you see the little blue point? Called it A? Haha! It went exactly where we expected. Okay, that's the end of today's video. Try the homework. Look at the U-Pick2 method. Try to find the intersection of 3 planes in a 3-dimensional space. Write the answer as an ordered triple. Have an excellent day. By the way, you do need graphing calculators by tomorrow. Okay? Bye.